let me redo it. What we are going to do today is doing this lecture on different kind of perspectives on human interaction, which is, in a way, the natural follow-up of the panels you had yesterday. So before starting this, if someone wants to summarize the panels in 10 minutes, each of them, separately. If not, I'm going to ask someone to do it, so better to volunteer. Or multiple people can also volunteer, it's not that. Well, the designer teams. That you are concentrated there, so it's easy. The second was about
understandability.
Uh-huh.
We had these two articles, one about CEIR.
Yeah, let's summarize the results, not just, let's assume that I know the process and the papers.
Okay.
The discussion was about...
Maybe I should have told you.
You have time to switch to the first panel if you prefer. Okay, and in the discussion there was something interesting that happened, or some topic,
yeah, we were
some contrast, some...
We were boxing each other. No, we were
No.
pretty much alike.
Lucky that I missed it, because otherwise the boxing would have been nice to see, no? Much alike.
Yeah, I don't know, maybe somebody else wants to.
No, they will talk about the second panel now, so... So let's move from the designer group to the bio, whatever it is, biomedical engineering and something else? No, just biomedical engineer? Okay, see, it was longer. So the second panel, because we were talking about understandability versus explainability, right, the last time, yeah, which was on understandability, and so so just by raising your hand, just to understand numbers, how many of the presents, of course, people present here, let me get the two panels. So how many of you were on the panel one, were on the artificial intelligence side? No one. Just, okay. And how many of you were on intelligent augmentation? I imagine everyone in that panel, okay. And here, well, here there's not a versus, but which one of you were more on the understandability? Well, let's say the first approach is better, slightly better than the second one. And then maybe the discussion evolved differently, but at the beginning, how many of you were saying the first approach is better?
I mean,
Well, someone raised the hand, so.
No, I will not raise the hand
For another one. And who well, that was neutral. But how many instead of the second one? Okay, how many neutral? Okay, and so. There was anyone neutral here? You need to make a decision, like. It was?
Expert level versus a consumer level. It depends on the user of the interface.
Yeah, but about the topic per se. After reading and after forming your own idea of what is, in this definition that we are going to see anyway, artificial intelligence and intelligent augmentation. If you have to, yes, this was the first one panel.
No, I am for AI, not
For artificial intelligence. Okay. Okay, good. Now let's go back here. So the panel should have, and probably add a little bit at least, made you think about different kind of perspective, because of course we had different opinions. There were in this paper different approaches. Is better automating, which is artificial intelligence, or is better augmenting, which is intelligent augmentation. And also in the understandability, which kind of understandability is different from explainability? If so, which are the pros and the cons of both? If not, why, etc. So these are all different perspectives. So let's start from the first one, and then we will briefly see also the latter one. So the question that in the panel also should have emerged a little bit is, should we design and then develop technology, whatever it is technology, that is artificial intelligence according to this definition? And the definition is artificial intelligence is a way to automatize people action so that we can replace human. So this is one definition, no? Not the definition we typically use, but back in 1960 or around that was one definition of artificial intelligence. Artificial intelligence was born as a way to automatize, as a way to replace human labor, human thinking, humans. And the other stuff, trying to make also, to use the same letters as initial, AI and intelligent augmentation, is instead we should augment people instead of replacing. So this is where there were two camps. One is we want to automatize all the things, and the other one is we don't want to automatize things. We want to give people better technology to augment their, so we don't want to replace human labor, human thinking, etc. We want to augment those things. So after the panel, you already partially replied to this, but is there a clear winner? In the panel, the majority of the panelists were more on the intelligent augmentation instead of artificial intelligence. But in general, now, if you think in general to technology, is always bad to automatize and is always good to augment, or is not just black and white, and there are shades of gray in the middle, or other colors, as you prefer?
I mean, one thing that came up also yesterday is it's really context-based, so depending on what you're actually consider as a context, probably the decision making.
Okay, let's make some examples. So in which context automation is good? Let's pick one example or two examples, just different context. So let's pick some context then.
I don't know, probably like the construction of something, which is already kind of automatized, so if it is even more automatized, probably it doesn't matter that much. And
So you're saying if already something is already automatized, we can automatize more.
yeah. I guess.
Can we do some concrete example? No, maybe not. Someone can do some concrete example, not just. Car manufacturing. So it's better automatize than augment people in that case.
Yeah. Because
So replace people.
yeah, because they can run 24/7.
Yes. Who was the fact? Who said the thing about capitalism? The dream of capital. What is one of you? Okay, so you can reply to him if you want.
It's also cheaper because when a machine breaks, you don't have
Okay, let's forget about money and economics. Why car manufacturing could be good in a automatized way?
because in this way you're sure that no human mistake can be embedded in the process.
That's not entirely true, but that's why cars have issues.
Yeah.
You know, it's not that they come up perfect.
No. Once you standardize the process, there is less variability because the machine behaves the same way every time.
Okay,
So
but
unless there is a weird error coming up, all the cars will be equal. So
still not a strong reason about this. What's the benefit?
I think it's not binary, it's always kind of a spectrum. So even, for instance, car manufacturing, at the end will still have someone human doing
Yep.
verification of everything. So would you call that intelligence augmentation?
No, that's a second step of the process, where the first step of the process is automated, and then there is a manual verification. But the step of the process is automated, because there is a step of the process was automated, no? The actual construction of building, of the car. Why it's...
Verification is also, so in the whole context of what the task is, verification is still main component of that.
Yeah, but I understand this. Let's move at the pre-verification stage.
If that's the case, I believe there are a lot of tasks that can replace humans, specifically tasks that are always the same steps, do not require critical thinking. Those kind of tasks could be replaceable.
So you were saying one pros to have automation is that if it's something boring, repetitive, and doesn't really put human in condition to perform at the best, whatever it means perform at the best, could be automated, because people would not really care, it's boring, is...
Yeah, but again, it's a spectrum. So it's another thing that I think was briefly discussed in the panels.
Yeah.
To what degree should we augment?
Yeah, but let's focus on car automation, just an simple example more on the future, right? But why again? I have one thing in mind about car manufacturing or any kind of manufacturing of big, heavy things that automation actually can bring a benefit. They are yeah, they minimize risk of issue with something heavy. I can get cut my hand, or I can be injured, or I can die. So for those cases, actually having a machine doing the work of the person is preserving the person's life. So in those specific cases, it makes a lot of sense to automatize. And then yes, of course, you can have other phases where human intervention can be useful, is important, is fundamental, but for the parts that are in the middle, instead, they could be maybe automatized. I think maybe an example of augmentation is slightly more difficult to do, but let's make us an example of augmentation. In a context, like car manufacturing, let's try to find something that is more augmentation. Augmentation.
surgical operations where surgical operation AI can estimate the odds and conditions and so that in order to
Also plan
That's augmentation or is collaboration? Or are the same?
Perhaps there is some kind of link to the accountability of the choices that derives from human AI interaction.
Yes, there are implications. I was just saying, let's pick an example. Like we pick car manufacturing, we pick an example of augmentation. Which is not collaboration. even if there is no AI, like, because in car manufacturing, we can also ignore AI, right? It's not that we, a washing machine is another example of automation. We are replacing human washing things. And also dishwasher is an example of automation. We are replacing humans. It's not AI. Well, now dishwasher have AI for no reasons, but still, it's an example of automation.
I was thinking about exoskeletor.
Yes, that's an extreme case, but yes, it's augmentation because it's augment people capabilities.
Maybe more than exoskeleton, like some of the guards
Yes. Yes, prosthetic, smart prosthetic, that you cannot do something, so it augments your capability in a way. No? This is more, one example. BCI. BCI in which sense is augmentation? Yes, no, I know what is BCI. I mean, in which sense is augmentation? For example?
Spanners for lockdown single people.
Oh, so some usage of BCI could be, yes. But this is more a way to interact and probably, so differently from the prosthetic arms or whatever, that you cannot do something or you can have the strength to do something. It's enable you to do this.
For some people, it's
Yes, for some people, yes. It's like saying I cannot use a mouse and then I find another device to do the things I was doing with the mouse. No, so it's more assistance, auxiliary tool than proper augmentation. It's not so different.
probably depends on the state of the network.
It's still more a tool to enable the person to do something. In the case of the smart prosthetic, yes, if I have an impairment, that's similar. But if I don't have an impairment and I have some exoskeleton or something, how do you call it, exorobotic arm, but also like a person not injured can use, that's augmenting the capability of, without going into the accessibility field. Okay. Let's make another example. And then so there is not a clear winner. What we are saying is that there's no clear winner. But let's make another example, which is also will be related to understandability, explainability. The Roomba, the vacuum cleaning robots. What they are? Automation or augmentation? Automation, because there's a robot that avoid me to clean. So it actually replace me. Good. Which are the problem? You see any? We were talking about implications before. Just was a comment about implication. I said yes, this is an implication of. And let's talk about implication. Do you see any implication in vacuum cleaner robots?
Scaring my cat.
Okay, scaring animals.
They get stuck.
They may get stuck if. Okay.
There was also the thing that, like, they can kind of like map how your house is.
That's a limitation of technology that maybe in 5 years will be solved. Or if you want to sell your data to someone, they also will be solved. Optimism. It's an implication. Or it was a comment about.
That we solve the problem of selling data about our home.
That's not optimism. This is sort of reality. If you like to give your data, they will solve the problem. Other implication on people.
You have to clean the machine once.
But that's like is surely less inconvenient than clean the house, and then you still have to clean the vacuum cleaner in some way, and also the manual one. So for a household, it's convenient, right? Let's not think about the household.
Perhaps we will not pay any
Exactly. No? If you have a machine that works well and you were paying a person to clean up, you are removing jobs.
Yeah.
No? And if you do it for your house, probably it doesn't make much difference. But if you employ vacuum cleaner robots in an industry, in a building of an industry and they work and they plan everything correctly so they can clean, you are saying to the people that do the cleaning of the building, we don't renew your contract. And maybe there were 15 people that you replace with 10 robots, 5 robots, whatever. Okay, so implication, no? There are always implications. Maybe it's not for the direct people that directly use them, but at large there could be other implication. Good. So if we think about human-AI interaction, human-AI collaboration, what do we envision? We envision, on the one side, full human control, or more in general, no human involvement. Full AI autonomy or no AI at all. In which cases? And we said that we tend to prefer, what do we tend to prefer? In this, yes, let's frame them in the phrase of these. What is augmentation? In these 2 bullet points. Is full human control? Yeah, because no human involvement, of course, is replacing human. And about autonomy?
Something in the middle, you know,
If AI is automation, not AI.
Now, in this case, let's consider AI like the normal definition of AI. So, technology that acts in some way unpredictably and with some undeterministic behavior and can generate stuff, etc. So something in the middle between full autonomy and no autonomy. And we discussed some cases like the car manufacturing, like the Roomba, etc. So, but the point here is that these things, automation and augmentation, are always seen as from one point to another point. On the one side, you have full human control. On the other side, you have no human involvement. And then you reduce human control, or you augment human control. And on the other side, you have full AI autonomy. And then as you remove AI autonomy, you give control to the human. So the traditional way, that is the engineering way to see this as a spectrum is, on the one side, we have no human control and full technology, automation control. And on the other side, we have no full human control and no control from the eye. And I think you can think an example again in the car system, let's say, in the car. Autonomous driving, no? And for cars, there are 7 stages, 7 levels of autonomy, from no autonomous car, which is current car we have, to fully autonomous car. And in each level, you choose a little bit of autonomy to the car or the people. So as more you move on the full autonomy, this is the classical engineering way. It's also the classical way to see this in a spectrum. Full control from technology means no control from human. And on the other side, full control of humans means no control on technology. Either totally manual or totally automated, with something in the middle that at a certain point removes stuff from one side to the other, to give them to the other, like in cars. Full manual car, full autonomous car. And in the middle, you have some degree of... So I put just here 2 examples of artificial intelligence in the definition, artificial intelligence and intelligent augmentation, from which I think you can understand which is my preference as well. So which is, to you, artificial intelligence of these 2 pictures, according to the definition we gave before, so this automation, and replacing human. This one. And the other one is augmentation. Now this is, of course, both are not real, But also this is augmentation, right? It's an exoskeleton, a robot, whatever we want to call it. And on the other side, what is this? Just to prove your knowledge of cartoons. WALL-E. And what are depicted here? Without spoiling the movie. Just in case someone wants and should watch the WALL-E movie, but what they are doing, these people. Yeah, they are doing nothing. They are totally replaced. They are just moved around as bag of potatoes. And the system, the technology will give them food, as you see from the slim size, the shape that they have. Food, entertainment. They don't even talk to each other because they're always busy. And they don't even walk because this chair where they are on moves around the place. That I'm not going to tell you what is this place because otherwise the movie. No, they don't decide anything in the movie. They just sit there and things happen, and they just are passive observer, and they don't think anymore either. But then they will start at the end of the movie, but you have to watch the movie to understand what happens. In the other case, it's augmentation because the person has full control of what happens, right? If we have in this spectrum of no control, full control, here people have absolutely no control. They just passive receiver, whatever happens. They eat when the system gives them something to eat. They don't even are able anymore to walk because they are not walking since years. So they lose the ability too. And on the other side, the person has still full control. There's a lot of technology to do things that otherwise were not possible to a human being, but still the person decides. The person has full control of technology. So this is an exemplification of intelligent augmentation versus artificial intelligence in this spectrum from no human control, full AI autonomy, and full AI control, and no AI autonomy, even if there is technology. So where did this definition came from? This definition, let's do a step back in the past. This definition stemmed from, again, I was saying the 1960, where there were the first definition of artificial intelligence and where the field was born. So John McCarthy in 1956 were saying to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. So this first idea, we can simulate every aspect of learning over any other feature of intelligence. So we can replicate the human thinking, brain, actions, etc. with a machine, 1955. And then a Nobel laureate, Herbert Simon, 9 years after, still in the 60s, and got a Nobel, so it's not just a random person walking on the street, publicly said that machine will be capable within 20 years to do any work that a man can do. Then, of course, 20 years passed, and we don't have machines that are able to do any work that a person can do, which is the problem with predictions. They are almost always wrong. But this was the idea of the founding father of artificial intelligence, simulating all intelligence, feature of intelligence of a person, and replace them, or having machine that can do any work, intellectual work, practical work, etc., that a person can do. So this also tells us that defining AI is not trivial, because in this definition it is clear that you want to simulate or replicate, but if we also reflect to our experience, our knowledge of AI, we can say that it's about building a human-like intelligence. Also, your definition of AI is about building a human-like intelligence, what's called AGI, or in general, or for some specific task, etc. So it's still difficult to define properly what is intelligence. Instead, we call smart things that are not smart at all, most of the time, but we still call artificial intelligence. And again, the goal, especially from some people working more deeper in AI, is to build this human-like intelligence. No? We reach parity on natural language understanding, which we didn't, but that was the proclamation. Or you can code a software application with ChatGPT and code and have it in 5 minutes and deploy it to the world and make money out of it, no? Replacing entirely jobs, etc. So replacing, replicating humans entirely. This is more, also the general AI is still in this venue, in this still way of thinking of let's replicate this human intelligence in a machine way. Intelligent augmentation, if we look at more or less the same timeline. So you have read the Ortwit paper in the panel that define intelligent augmentation as an elegant combination of reasoning machinery and direct manipulation. This doesn't talk about intelligence, talk about reasoning machinery for the machine. But if you went back a little bit, the same time of the other two, we have in 1962 Douglas Engelbart that has an entire research project that was called Augmenting the Human Intellect with Technology. And Licklider, they would say computing machinery will do the routinizable work that must be done to prepare the way for insights and decision in technical and scientific thinking. So we have machines that do the work that is routinizable, similar to the Roomba, similar to add cleaning data, etc. But then the things that need thinking is left to the humans. So creativity we mentioned before, etc. So these are instead the definition of what then was called intelligent augmentation. Okay, so do you know, well, I need to stop 1 second. Do you know who is at least the computer science plus designer? The other are excuses. Who is Douglas Engelbart? So go after the class, go on the web and search for Douglas Engelbart and the mother of all demo, because the demo that he had on this project is considered still today the mother of all demo for how well has been conducted as a demo of a product, a demo of a computer service. Okay. Well, here there is a definition of direct manipulation if you don't know what it is, but probably also in the paper. So, but let's do a step back. So these people were talking about replacing people, simulating any aspects of learning, doing any job, augmenting the human intellect, aiming machine to prepare the way for insight and decision by human in 1960. So how was the world in 1960? How was the technological world in 1960? There was no Google, there was no Wi-Fi, there was no internet. So, but they were talking about this. So let's put that a little bit in context. So in the 30-40, we had the early start of modern computer science. So they were just 20 years after. In the 1956, we had for the first time in research at MIT a keyboard connected directly to the computer. So when they were saying machine to simulate people, they didn't have a keyboard connected directly to a computer. So they were behind their time. The first computer, not personal computer, the first computer in a way that is similar to what we understand is in the 1966. So after all these people, except Horowitz, came up with this definition and worked on this stuff. And the first computer was something like this. So this was the entire computer. The entire desk was the computer. Okay? Just to put them in context a little bit. So we are now reading this definition, thinking of the AI we have, and thinking of the technology we have, for which I can have PowerPoint running on a computer which is connected to 2 microphones and projecting here and connected to Wi-Fi. But where they were thinking those things and making this prediction, they didn't even have this in the picture. They have huge rooms of computers with cards to insert into them to operate, and wait time, very, very long wait time, and few of them. And you had to physically go in the room and know what to do, because otherwise it doesn't work. So let's make another example. Also, this is something that, again, computer science and design should know. So consider this also a learning opportunity. Vannevar Bush in 1945 wrote this in a magazine newspaper that this was entitled "As We May Think," talking about a future device. Of course, 1945, we just were in the early start of modern computer science, so almost mathematics. And we say, consider a future device in which an individual stores all his books, records, and communication, and which is mechanized so that it may be consulted with exceeding speed and flexibility. It is an enlarged, intimate supplement to his memory. And here you have the picture, but we can also click on this link. Now let me do this. So while I'm copying this link, which thing we have now, this reminds you to? This description reminds you to? Something to store all books, record, communication, mechanized so that it may be consulted with speed and flexibility to enlarge, to supplement people's memory. Well, they are all almost good answers. It's YouTube, so there is advertisement. Okay. Okay, skip. So this device was called Memex and was drawn in this way. Again, 1945, so was an entire desk, because of course computers were large as rooms, already imagining this. But the idea was this.
The owner of the Memex, let us say, is interested in the properties of the bow and arrow. He has dozens of possibly pertinent books and articles in his Memex. First he runs through an encyclopedia, finds an interesting but sketchy article, and leaves it projected. Next, in history, he finds another pertinent item and ties the two together. Thus he goes, building a trail of many items. Occasionally, he inserts a comment of his own, either linking it into the main trail or joining it by a side trail to a particular item. His trails do not fade. Several years later, his talk with a friend turns to the Turkish bow. In fact, he has a trail on it. It is an interesting trail, pertinent to the discussion. So he sets a reproducer in action, photographs the whole trail out, and passes it to his friend for insertion in his own Memex.
Okay, so you get the point. So this was what Vanderbilt Bush described in this paper, 1945. And this was actually, well, is this, I don't know if there is a question, yes. So is this augmentation considering technology in those years, no? Is this more augmentation or more automation? This is absolute augmentation because it's a device to remember things, to store information, to combine information, to move from one piece of information to a similar piece of information. So the trail are sort of documents that were created on a specific topic and then can be retrieved the year after. So it's a way to augment human memory. Of course, it's for us to be very, very simple because now we have access to a wide variety. But again, 1945, just a few years ago, different context, different word. This was, as just a curiosity, there was the second question. Does it look like to be related to any current piece of technology? This was publicly said it was an inspiration for something that we have today, not a physical device, but was explicitly said it was used as an inspiration, strong inspiration from something that we have today, and we still use today. Think about the operation of this thing. I go to an encyclopedia, I see something, I say something, and then I find other things, I put them together, I can move from one piece of information to another piece of information easily, I can retrieve information, I can create my own set of things, I don't want to say another word, the web. No? Wikipedia could be the encyclopedia, you can copy and paste, you can create your own document, you can save them. You can, the possibility to move from one document to the other was the inspiration to the link. So, I missed the name of the creator of the web, sorry, I just have a blackout now. Sorry? Bernard-Lee, sir, was the creator of the web. He, when he created that, just said that this was an inspiration for it, and he worked in related, let's say, to the field that is let's say, closer to human-computer interaction. He just retired from the University of Oxford and wrote a book about the early years of the web. And he was, I was saying, he was in the human-centered computing group where he was working at Oxford recently. So this was an inspiration for that part, as a way to supplement the memory, access to information, etc. Okay, so let's do other example, some older, some newer, and let's try to understand if this is more augmentation, is more automation. The answer, the question is always about either the assumption or either if it is augmentation or automation. So let's look at this. This is 1980. We move a little bit closer, but that's a paper in the SIGGRAPH conference. That is a demo of a paper at SIGGRAPH conference.
Create a yellow circle there. Create a cyan triangle there. Put a magenta square there. Create a blue diamond there. Move that there. Put that there. Move that below that. Move that west of the diamond. Create a large green circle there. Oh, shit. Restart.
So again, 9080, but we can say that we have some AI in a way here, now the speech recognition part, and the put this there, west, below, etc. And there is interaction, of course. So let's try to answer this question about speech recognition. Why do you need to point? Why do you need to talk? And what might go wrong? About speech recognition, why do you need to point? Why don't you say, put something there?
Because it doesn't have the spatial awareness of like what are the limits. So you need to kind of use some coordinates.
Other way to do this could be put the triangle, because there were some like awareness of things like create a large red circle. So large. What means large? No, it was larger than the others, but was large enough? Probably for a demo, yes, but in general. So you could say put them. He also said like put these west off, below off. So not always pointing. So why not having other way to describe?
There is not specific.
Hmm?
There is not specific.
Yes.
You have to give like coordinates.
Yes, and which is good, why? Or bad, why? Or the point being?
Just a matter of the algorithm cannot understand there because it's random.
Yeah, but why you need to point? Again, I could reply with okay, but he could say put this 5 centimeter from the top corner or from the side, the left side, or 10 centimeter, or half the screen, a quarter of the screen. You don't need contextual awareness. You don't need specific coordinate because you can relate in centimeters or inches, probably in that case. Okay, to engage could be a better answer. Makes use, why it makes use of our ability to make in space? We are used to it. So it's simple for us to say, turn on that light. We all understand which is that light, no? So it's simple for us. You can find other way to do it. 5 centimeter, 10 centimeter below, west, east, etc. But then you have to remember that is not left to the triangle, but is west of the triangle. It's not below it's not south, but is below, etc. So why do you need to talk? You could have said with the mouse, just pointing, double clicking, contextual menu, and created triangles. It's not that we are not creating figures. If we want, we can create some picture here and just drawing them. So why pointing is natural, is more intuitive, okay. Then setting coordinate to say 5 centimeters, and then I have to remember things. But since I have to remember things, I have to remember commands, even if simple like put this, that, or there, or move this, that, there, or below, west, etc. But still I need to remember some specific commands. Can we avoid talking? Can we do the same things without talking? So why they thought that was pretty much good to talk?
In order to humanize the interaction, perhaps. I don't know.
I don't know, but explain humanized interaction.
Maybe when I interact with someone else, some human, I perhaps for sure I will talk. they were trying to translate the kind of interaction with the machines.
Yeah, that could be, well, I don't know either because I didn't talk with Richard Bolt. Yeah, either, but yes, these are good hypotheses, right? Again, similar to before, we need to point, we need to talk. They thought it was a good idea because are more immediate, are things we are used to. It's not that. And yes, you have to remember some words, but for most of them, it's put this there. So not a large vocabulary to remember. What might go wrong? Which is always a question you should ask yourself when creating or designing technology. Even in this case, which is like putting triangles on a screen that is not like life-saving as an activity, what might go wrong? Where the system can stop working or not? Yeah, you lose. If you need precision, it's difficult to have it, of course. Even pointing, put here, that, no? You cannot be very, very specific, very, very precise. Also, the video is not, if you see what happens in the video, is not very precise as well.
Or not understanding command at all.
You cannot understand commands at all, like instead of move something, move another thing, instead of creating a large red circle, creates just not a large circle, yeah. Yeah, the system cannot recognize, understand what you say. Anything else? Otherwise, we move on. Language access. Of course, this is, well, yes. Of course, this is like, well, of course, this is what might go wrong if you, this is a room with a big screen, but if you imagine it, and it's a research project. If you imagine it like deployed somewhere, then of course you need a quiet room, being alone, etc. Because if there are other voices, that will be confused, the system. No? So there are all things that can go wrong. This is about people. This is a way to augment them, the capability to, in a simple way, but the capability to draw, to move pieces. Triangles, circles, changing color, etc., and it might fail with the reason that we said. Now, we said before that one aspect is of artificial intelligence, also intelligent augmentation, is this intelligence that it's difficult to measure and define. No, okay, how can we define intelligence? What is intelligent? It's hard to define. It's not probably impossible. I imagine there are some philosopher or that can define intelligence. But see, if we need to apply, say, okay, is this intelligent or not? Which are the attributes of intelligence? Well, this is a battle, so of course, is not. And we can recognize this level. But then, if we move towards living things or more autonomous things, then the difference is maybe more difficult. So one thing to measure intelligence that is possible to do is not directly measuring intelligence, but measure the joint performance of a task for a human together with AI. So not separately, not I give you a task and then give the same task to the machine and I compare them because they are different entities that work with different rules. I can also do a program to do very well that task that the person is not suitable for, and then, but maybe the machine doesn't do any other task. And so it's an unfair comparison. So a way to measure intelligence is try to understand how human and machine together, so collaboration, as we said before, can achieve something that a human or the machine alone cannot, or would do worse. So it's not giving a person a task and giving the same task to the machine and seeing who is doing better, but saying, okay, the human is not very good in doing this typically, the machine is not very good, cannot do it, or is not very good to do it alone, and we know that. So let's put them together and we see if there is an improvement with the individual, let's say, performance and with the capability. So a way to measure intelligence is to explore collaboration. And here there is an example of this. I don't know if, yes. Here there's an example of this. Do you have any idea what is this? This picture. What is doing this person? Playing chess. Okay, that's the baseline. But there is a computer, right? This person uses a computer. And also here there's another computer and there's another person that play with the white and this person play with the black. Why they have a computer?
Perhaps they are simulating the future. They are training.
They are
Training.
the computer is telling them, they are learning from the computer. They were, you said?
Perhaps simulating future moves.
Simulating.
Simulation for time. The computer is way far faster than you want to simulate.
Any other options? They are programming the computer. This is a kind of chess playing that I don't remember the name in this moment, in which they do something similar to what I was saying. So the player play chess, but they are not learning from the computer, they're not programming the computer, but they're using the computer to understand. So given the situation on the board, here you can see a little bit the board, and the person can say, okay, if I move here, the other person what can do? And then it's informed, give data, give information, and then the person decide that, okay, now I can move here. And the other person do the same thing. So a computer, we know that a computer can play chess and also win in some cases, in many cases, or some cases, the digital version at least. But here they want to explore collaboration. So it's not a super fancy, intelligent algorithm. It's just prediction, simulation, what happened next, and then the person is in charge of deciding. So there is collaboration between the two. If I do this, what happens? Okay, if I do that, what happens? And the computer can give a recommendation, and then the person can decide. And on this line, for instance, there are these robots. These are called cobot, collaborative robots. That follow this model of symbiotic autonomy, in which the robots made like this, so not in a humanized form, are aware, the robots are aware of the perceptual, physical, and reasoning limitation that they have. So again, they're not super powered by artificial intelligence, it's pretty normal robot, they can go around, press button, bring things, but they have a limitation, and they're aware of their own limitation, and ask for help when they cannot do something. And this was a project. If you look at this video here, we are not going to. But if you look at this video here, you see these were deployed in CMU in Pittsburgh, and they were going around. So I can say, there is the video in that I can say, go and take this visitor to the elevator, and they will go and display on the screen, hello, name of the person, follow me, and then the person will follow you. Or can I have another bottle of water? And we'll put the water on the robot, and then the robot will go in the kitchen, and since it doesn't have arms, through the screen, to the voice, we say, hey, whoever is in the room, can you fill this up? And another person will put the water inside, and will put it back, and the robot will go back to the person. So it's to the person who's asked for water. So it's collaboration, in a way. But the important thing here is that the robots were aware that they were not able to do everything, just something. And they were aware of their own limitation. So is this augmentation or automation? The robots, not the chess. Or it's more augmentation, it's more automation. It's more automation, because you are replacing the person going to the elevator. You are replacing the person but not entirely. At a certain point, you need human intervention to do things that the robot is not able to do. So instead, like ChatGPT in the first lecture, instead of confidently being wrong or trying to do things that the robot cannot do and making mistakes, just remove the problem. You say, okay, I cannot do this perfectly, and then I will ask a person to do it for me. But I can go and show on the screen something, so I will do it. Well, I'm not asking all the questions, but what can go wrong? Imagine to have these robots deployed here that runs, following your commands. What can go wrong? They will obey to someone else. Yeah. So I ask them for bring me a cup of coffee, and then someone say, no, don't go, and they will stop there. Yeah. So they need a collaborative environment from the humans. Then?
They can also be told to do something harmful for themselves.
Yeah. Yeah, maybe. Yes, it depends how they are programmed for the limitations, of course. Then? Look at them also. They are made like this. So they are slightly different, but they are like pieces of stuff that go around. It's not a human form, not nice, not just screens with some wheels and camera. They will be, in your opinion, immediately accepted by everyone? Or maybe there will be resistance? Trust. Yeah? So maybe the people that were in the department, they knew about the project, and okay, let's play with this. But if you have a visitor and you find a robot waiting for you with a screen, do you trust him, the follow the robot, or say no? Or you have some hesitant, or if you have a child or an elderly person. And then the robot at a certain point maybe needs you to help with something that it's not able to do. You will help the robot or not? So all these things can be point of attention from an interaction perspective. Again, AI here is the robot doing things on their own. But even in automation, even when we give full control to AI or to technology, it's still important from the literature, from the studies, that people are still feeling control. Maybe they don't have control, but they need to feel to have control of their lives and surroundings in some form. So when we put intelligence, when we put AI in things, people should at least have these three characteristics. They should be comfortable with the action made by an intelligence system. If they are not comfortable, they will not feel in control. They will need to understand, which is different again from explainability. They need to understand why some action is happening, and again, be comfortable with the action. And they need to trust the intelligence system. And of course, you can build trust by being comfortable and understanding. Automation is typically met with resistance if you think also to the history. However, it can reduce the workload and allow to complete dangerous tasks, like we were saying before. And of course, we should avoid over-exaggerating expectation, like we have reached human parity in speech recognition, which Microsoft did 5 years ago, and we didn't reach human parity yet. That's an expectation claimed, or there are expectations that are pre-assumed. So do you have experience with like Alexa and stuff like that? No, right? Use at least once. What's the expectation of people with those things? Yeah, but what's the expectation, which is written here? So I will. Intelligence, we are not able to measure intelligence, but
And it works all the time.
what means works over the time? If a course works over the time.
For example, like Alexa never understands me.
Yeah, what is the expectation then?
That understands what you're actually saying and replies accordingly to what you're saying.
Yes, the expectation is since I can talk with the thing, and I'm used to talk with other people that have large understanding of what happens and provide typical answer that is coherent with my question or my assumption or my whatever I said, then since these things talk and listen, my assumption is that we work anyway, at the same way. I can say whatever I want and this thing will understand me fully. That's the expectation. This is a natural expectation because the only experience we have with other talking beings are with humans. And so when we give for the first time to someone things like this, that's the immediate expectation. If nobody say, no, you have to learn exactly what to say, otherwise you cannot ask whatever. But if you want to ask about the weather, you have to formulate a phrase in this 5 different way, otherwise you may not get a right answer, and be closer and not in a noise environment, etc., etc. You set the expectation. But otherwise, the expectation is, I can speak with it, it understands my words, thus it has full language understanding, which is not. At some sort, predefined language understanding. Let me see if I want to do this or this. So do you know what is Amazon Go? Yes. So video time.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We use computer vision, deep learning algorithms, and sensor fusion, much like you find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
Okay, so this is, This is an advertisement, of course, of Amazon when they open these shops. So the question above there, what do you think? Cool, not cool? Is everything totally fine? And why, if it's not, why is this accepted? Because there are stores like this open and they're still open, and people use it. So. And here there is a lot of AI. So. So?
There were people marketing, right? There were people watching camera feeds, and it was like actual humans. It wasn't a reservation.
Well, let's say it is automation.
Well,
Like in the advertisement, they use sensor fusion, machine learning, and whatever. Well, some parts are of course automated, no? But would you go to shop in a place like this? Okay, why not? Or why yes? I don't know if.
that's my moral objection, but money exists to also
prefer human interaction, let's say. Others. Would you go to a shop like this? Of course, the computer engineer will go. That's absolutely normal and expected.
As long as it works, I just don't care how they process. And as long as I'm aware that they use my data, my face.
Well, they will of course use your data, your face. What you are saying, that's a privacy nightmare. That by definition is a privacy nightmare. It cannot be. It's also Amazon. So how many advertising you get about the things you bought last month and after? So
If I'm okay with that,
if you're okay with that,
I already saw
well, there are people that go there. So of course they will okay with that. Anyone else? This is again sort of automation because we are replacing people, as she was saying, and for convenience, which is the definition of automation most of the time, or for safety reasons, but we are replacing people, we are replacing, to convenience, not to have a lines, not to have a checkout, just go there, buy something, and I will go out and charge it on your credit card that registered on the Amazon service, on the Amazon app. And you can check what you bought, so if there's an error, you can also complain. So anyone else? At least one, then we will move on. So we had the yes, I will go, and then no, I will never go, and yes, you need to have a yes, you need to have a smartphone, there's Amazon app, an Amazon account, and internet connection, and all of this should work, because otherwise you don't go out because they cannot process, or go in, you cannot process. Would you go? No. Why? You have a smartphone, no?
Yes, but I don't trust this type of
It's, you don't trust. Again, no, I'm fine. I'm fine with that. I'm fine with that definition because it will bring me back here. So when we put intelligent in things, we should be sure that people are comfortable with the action by the system, and Andrea is, understand where some action happening, that maybe is harder to understand exactly why things are happening this way, and then trust the system. So if these three characteristics are missing, even just one is missing, you can be comfortable, you can understand, but you don't trust the system, the company, etc., then you don't feel in control, and then you don't really want to use this advanced technology, especially when there is advanced technology. Okay? We skip the full driving draw. So last topic. We have seen up to now, and I also presented to you the engineering, let's say, way of seeing automation and augmentation. Full human control, no intelligence, no technology, no things, and on the other side, full AI control, full autonomous, no human control. But when we gave the definition last week of human-centered AI, we said that human-centered AI focus on amplifying, augmenting, and enhancing human performance, which sounds very much like augmentation. It's also one of the verbs, in a way that make the AI system reliable, safe, and trustworthy. Now, to have a system that is reliable, safe, and trustworthy, you should keep at least feeling control, no, of people. So the point of human-centered AI is that, yes, we can have this spectrum, no AI, full AI control, full human control, but we can also have full automation and full human control. Do you feel, in some cases, at least. Do you think at least one example from the real world where you have a lot of AI, a lot of automation, and there are things that happens anyway, even if you don't control them at all, but you have full control on the process?
Self-driving car is not.
No, self-driving car are exactly in the spectrum, because something that you have all with you, and either you're using it or you're on your desk at the moment, that is portable, and it has, which is a smartphone, and it has something, an application, it's a stock application, that's one example that came to my mind. A stock application in the smartphone that has a high level of automation, does a lot of things without you controlling any of that normally, but then you have full control on the entire process of this application. What you do with this application? No, search engine is not an it's not an application that you have on your phone, no? What is the automation in the calculator? Okay. That's not like particularly automation, like it's just applying formulas. So no, it's a stock application. An application is already installed on all the phones. Doesn't matter if they're Apple, Google, Samsung, whatever. All the phones have them. What is the automating in the calendar? Where is full automation in the calendar? And where is the automation in the alarm? Makes sound, no. That's just a counter, it's not. We were talking things a little bit more like intelligent and complex in a way. For which you need this. The camera app. The camera app in modern smartphone has a lot of automation. It's stabilizer. It's contrast enhancer. I take 5 photos and then I will show you just one, which is the best, or the combination of all of this is automation, or this is some machine learning algorithm. Most of this is some machine learning algorithm. But you have the full control. It's not that the camera makes photos without you. You decide where to point the camera. You decide if it's a landscape or not. You can decide if enabling some modes or not, the zoom. You decide when to take the photo. You have full control, real full control. But then under the hood, there are a lot of technology, a lot of algorithm that will try to make the photo better. So even if you are shaking, the photo will try to stay not in a stable way, because there are stabilizers that do that. If there is low light, there will be an algorithm that will try to make the photo visible, not just all dark. This is a lot of AI, a lot of automation. That happens that you have, for most of it, absolutely no control. Some of that you can disable it, maybe with some other apps. You can disable it, but for others, they're just there and they work. You maybe can access the raw photos, but then the normal photos, but it's different, no? The normal photo is done with this. So this is one simple example, something that has a lot of automation, but gives you a lot of human control. So the things we have seen today, the spectrum, is human control in contraposition automation. The things the human-centered AI wants to make is, yes, you can have a lot of human control and low automation. Yes, you can have a lot of automation and low human control, but you can also have low human control and low automation, which is simple things. And also you can have a lot of automation and a lot of human control. So the definition of human-centered AI, as it is done, say that the things here, if you do something here, is easier to obtain reliable, safe, and trustworthy situation, because you maintain high human control, which is something that people want, control on the things they do, and also you add high automation. So in a way, you pick the best of both worlds. Again, not everything could be here, but something could. Like the camera is a small example of it. Other things should be in the other quarter of this diagram, but some others can be moved here, so can be designed in a way that they have full automation and full human control together. And you can read more on the paper, on this paper here, but the point is here things are easier for things to be reliable, safe, and trustworthy. In the other quadrants, you have to pay way more attention. An evolution of that, in a way, is when we talk about interactive human-centered AI, in which we don't only have the characteristics as before, but also we enable interactive exploration in real time and manipulation, which is connected also with understandability in a way, because we talk about observable intelligence. So something that, so a channel in which the AI algorithm can support the user, and the user can control something about the algorithm itself. And here there are some properties for interactive human-centered. I will just skip them quickly because you will talk with Tommaso about designing and evaluating, and that will be a larger portion of this. But if you look at this, you can see that individuals can, one property is that individual can interact in real time with the algorithms, with the model, not just with the interface, but with the actual AI system, and can manipulate and control all relevant parameters, where of course the tricky part is what is relevant. Could be everything, could be just a portion of it, it depends. This is interactive human-centered AI, where it's exactly as before, but the interaction is in real time. Any change of these can be observed in real time, and there is exploration on how specific decisions are made. So not just I explain to you, but the person can explore why this is happening. I'm asking the system why this is happening. With some caveat, like in fast processes, if you want to allow interaction, I can reduce the speed of the process. I can make it slower because otherwise it's not observable, it's not interacting with. It states how humans can benefit, that's similar to human-centered AI. It explains what risk the AI poses in a way similar to what I ask you, what can go wrong? It asks what can go wrong. It's visible what's control, and it's visible also which data, knowledge, and information is used to create and inform the AI. So these are all properties. So let me say two things about understanding system, which is linked with the understandability. Do you know this case of HAII? It's 10 years ago now, but it was a big fuss about it, as you can see here. Do you ever heard about this? What is this?
No,
You say yes, so.
Yeah, I knew that they created this chatbot, and then it became.
Yeah, that is a very short story. The longer story, a slightly longer story, is that they created this chatbot. So Microsoft created this chatbot, and it worked in the lab. They also deployed on, I think, WeChat in China, and everything went well, no problem at all. And so they said, why not, after quite a lot of time, why not deploying it on Twitter? And on Twitter, in less than a day, the chatbot started to give racist answers in less than 24 hours. It was tested in the lab, it was deployed in WeChat with real people, and the chat was learning about the conversation that we had on WeChat, and they had zero problem. But then they moved it on Twitter, and they had huge problem in 24 hours. And they shut down the project as a result. So the system was working, the AI part was working, this was learning from people in WeChat, so no problem there. As soon as they put on Twitter, X nowadays, just became a racist asshole, as this The Guardian paper was saying. Why? What happened? Same system, same technology, interact with people in WeChat, so it's not that it never interacted with people. What wasn't considered by Microsoft researcher in this case? Hmm? But the system was observing conversations. The kind of people on Twitter that interacted with, or the kind of conversation that people on Twitter interacted with respect to the people on WeChat, which is still, again, largely popular, and with a lot of users. It's not that there was nobody there. But yes, the kind of conversation was exposed made the system go absolutely raw in less than 24 hours. But terrible things, not just non-politically correct things, just very bad things. So understanding, in this case, was not just opening the code, which is not understandable, but considering the context, consider where this is deployed. Not just, oh, there are people, but it worked with people. Let's move it to another platform, and will be the same. It's not, because the kind of conversation happening on Twitter, the kind of people, the kind of polarization that is on Twitter, that was on Twitter in 2016, and now is probably even more pronounced than 10 years ago, made the system behave in a totally different way. Absolutely totally different way. So it's important, and again, this is linked to what you will see next week and in 2 weeks. Design goals and functionality that the AI system is supposed to support, and understand the context, where this is deployed, and asking again, as the properties before, what can go wrong, which are the risks. In that case, the risk is that the chatbot just learn things that shouldn't have learned, with no guardrails, with no control, etc. Even it was tested for months on another social platform with a huge number of people, even if, and now, there was no problem. You change the context, and you don't ask yourself, is it the same context? Is it the same kind of conversation? Did we put something in place, which was the goal of having the chatbot in the first place in these social networks? Which are the functionality? What do we want to support people to do? If you don't ask this question, you will end up likely with this situation if you end up in the wrong context, like this is one. And to understand, here there are some distinct elements to keep in mind. One can review the output, that is a selection of what the AI system is producing. You can have a way to insert correction or creation new sample to drive the discussion, or to remove, to add some guardrails. You can, of course, inspect the model quality, evaluate the model itself after deploying it for a while and see if there are problems. And of course, you can also contextualizing tasks to help the assessment by users in a specific context. What's working, what's not working, is helpful, is not helpful, etc. But again, most of these is about adding people interacting with the AI system, not just seeing a conclusion matrix on a screen, for understandability, for explainability of how the system behave in real-world setting. Okay, so this close about the lecture was about different perspectives. So we have the perspective of collaboration. We had the perspective about augmentation and automation, and this trying to have a new frame in which we can have both in some cases, and the perspective that also we need to understand how things work and not just test them in separate environment without asking which are the goals, which are the functions, because otherwise we can easily go in a situation like this, in which in some cases it works very well, and then one case is a complete disaster. Okay? And with this, any questions? Otherwise, we will stop here. Okay, good. So next week, you will start without me, I think. Let me check, and then we're going to go. Next week, you will again start designing the evaluating interactive system on Tuesday, and then Wednesday there is group work. Remember to complete the work, the teams, the groups on the shared spreadsheet by Monday, so that here on Wednesday you can actually start work with the team that you have. Then we will talk slightly about the conversational agent, and then we will have another, the final case study. So this design evaluation workshop is the work that you will do next week, and then you will have to deliver similar to what you did for the panel on the same bad user interface for uploading files. This time in group, so one file per group, but there will be a template to fill out. Then again, we will talk briefly about the conversational agent, what changed, and give you some hints to do the case study that will bring you to the end of the course. Okay? So next week, we will not meet. There will be Tommaso, and we will see again each other on February 10. Okay? Good. And with that, have a good evening, and see you in 2 weeks.